Hello, welcome to the video notes for lesson 6-6. This lesson is factoring the difference of two perfect squares. Okay, this is a very interesting lesson and interesting form of factoring. We're going to be dealing with polynomials that look like this: ax squared minus c. A and c are going to be some integers or some numbers. So our learning target: I can factor the difference of two perfect squares, and it looks like this. Now, in order to see this, just like with the previous two lessons, I'm going to have you go through and expand or multiply all these binomials on your own. And then, once we see what they look like when they're expanded, we are going to understand a little bit more about what the factored form will look like. And this is going to take a lot of practice. So what I need for you to do is pause the video. I'm going to pause it on my end. So for you, it'll just look like it'll go from this right to all the answers all of a sudden being up on the screen. After you expand it, then hit play, and you will be able to compare your answers with mine. All right, here we go. Okay, we are back. That took me a couple minutes. I wonder how long it took you. I did show all my work so that you can see where the answers come from, and I want you to compare yours with mine. Hopefully, as you are going through and doing all these, you recognize that because we have inverse or opposite terms in the middle, when you combine that middle set of terms, they cancel out. And our final answer is not a trinomial, but a binomial. And that's where the difference of two perfect squares, the name of this, comes from. So if I look at the first one, x squared, that's a perfect square, minus, that's the difference, and 25, that's a perfect square. All of these have that same type of situation. Now, some of them look different, like number 4, we've got x to the 4th power minus 81. Some of you might look at that and say, well, that's not a perfect square. But it is. It's the square of x squared. Now, I know that gets a little confusing, but with enough practice, you'll start to see and recognize these, and they actually become pretty simple and easy to handle. I will warn you about number 5. That is one that is designed so you can see what it looks like when there is a coefficient in front of the first term. But that can actually be simplified even further because that there is a common factor of 4 for these two terms. But just for this example, I wanted to leave it like that. And actually, let me go all the way down to the bottom. I could make the same statement about this last one as well. Both 36 and 16 we can factor out a 4 from those and make it even a more simplified answer. Anyways, so these are examples of the difference of perfect squares. Now, what you have to recognize is basically when we're going to go inverse or opposite of what we did and factor these, we need to identify that these are both perfect squares and what happens when you take the square root. When you take the square root, those are the two terms that you are going to end up with for your factors. All right? And I think it's easier to see it over on page 17 if we start doing some examples. So on page 17, up at the top, when I look at the first one, I've got x squared minus 49. Now, because I have the difference of two perfect squares, I look at the first one and I say, okay, what's the square root of x squared? It's x. So I have two x's. If you want to set yours up like this. Now, because it's a difference, I have to have different operations or inverse operation. And then the square root of 49 is 7. And there you go. Now, as a check, you can just expand it out, and you should end up with the same answer. So the next one, 25x squared minus 81. 25x squared comes from 5x and 5x. 81 comes from 9 and 9. And since it's a difference, we need to have a plus and a minus. Alright, pretty simple. Maybe I'll do one more with you and then let you try the rest on your own. We could take a look at this one here. Now this can be, again, done in a couple different ways. First thing you could do is you could factor out a 4, but we'll leave it as it is because they are still two perfect squares. 4x squared, if I take the square root of that, I get 2x and 2x. And I know it's going to be a plus and a minus here. And 36 comes from 6 and 6, and you're done. Pretty easy, right? Alright, there's a whole bunch of problems left on this page. The video is nice and short, so you've got lots of time to finish. Well, there's not a whole bunch, there's 5 more. See what you can do with these. If you get stuck on the last couple, I know they're a little tricky. Bring your questions to class, but at least try it on your own and see how you do. And if you had any trouble, go back and rewatch the video, see if you can, or look at the previous page, page 16, and see what happens and how we expanded those and multiplied, and that can sometimes help you to see where these come from, where these terms come from. All right, good luck, and we will see you in math.